A very warm welcome to you, grade 5s. Today's lesson was focused on Companion G5, page 29. Now, because of the difficulties that we had in the morning, I decided that I'm going to voice over the same lesson just so you guys could review it. So this is what we are going to do today. We are going to recognize right angles. We are also going to look at two-dimensional shapes and compare them according to their angle size. In front of you is what we call the Hiele Mosaic puzzle. As you can see on the screen, this puzzle is made up of different two-dimensional shapes which all together form a rectangle. Now, to see this, you can go to your G5 book on page 77. Now, on the next slide, I'm going to tell you just in brief about the Hiele Mosaic puzzle. So the colorful, beautiful puzzle is named after a man called Hiele, based on his beliefs on different levels of geometric thinking. Ultimately, his puzzles use the 7 different shaped pieces of a mosaic that together form a rectangle. These puzzles help us to explore how different shapes can be combined to make a new shape. They can also help us to discover that there is not only just one answer and that there are many different ways to find a solution. Now, if you go to page 77 as well as page 29, you will realize that this is how the puzzle appears. It is numbered to show you that it is made up of 7 different parts of two-dimensional shapes. So now, our focus today is going to be on piece number 5. In isolation, piece number 5 looks like this. It is a regular triangle, but it has a special type of property, and it is called a right-angled triangle. Now, before I move on to the next slide, I just want to explain what angles are. When two lines meet at a point, which is mathematically known as a vertex, an angle is formed. These two lines are called the arms of the angle, and the angles are measured in degrees. So boys and girls, a right angle is an angle equal to a quarter of a complete turn. Let me just unpack this for you. We said that when two lines, this is a line and this is another line. But when these two lines meet at a common point, which is this point over here, which is known as the vertex, an angle is formed, and this is the angle. And because the angle is a 90 degrees angle, it will be marked with a square. I will explain this on the next slides. Now, it's very important that we understand that an angle has got parts. In an angle, we have what we call arms, and we also have what we call a vertex. So the two rays or lines joining to form an angle are called the arms of the angle. These are the lines we are talking about. When these two lines join together at a common point, which is the vertex, then they form an angle as you can see here. Now, for us to be more specific, we can go on ahead and label our arms using any letters of the alphabet that we would like to. So here, OA is the name of this arm and OB is the name of the arm. The vertex, like I said, is the common point or the common end point at which these two lines meet to form an angle, and it is known as a vertex. Right. Boys and girls, here are some few examples of real life angles. If you take a scissor and you open it, you will see that it forms lines which join at a common point and they form an angle. This will then be your common point and this will be your line and that will be your other line. And then angle is formed. Take a look at your hockey stick, for instance. It has a bending. Right over here, the lines are joined. At this point, that's where we find our vertex. Take a look at your chair. It has got lines, and where the two lines join or where the two wooden planks join will be our vertex. And then a real life example of an angle is formed like that. As you can see, this looks like a right angle because it has an L shape. I'm going to discuss that in detail with you. Now, boys and girls, the focus for today is on right angles. But for interest's sake, it's important for you to know that we have different types of angles. And these angles have different sizes. And these sizes can be measured using what we call a protractor. Remember that I always tell you that with measurement, there's always an appropriate tool that is used to make measurements or to take measurements. Now, just going to run down the different types of angles that you can get. There's an acute angle. Now, this is an angle which is less than 90 degrees. Here I've given you 62 degrees, so that is less than 90. Now, the focus of today is what we call the right angle. Right angle is exactly 90 degrees, and it always makes the L shape. Can you see that this is an L shape? And now the angle is marked with a block. Or take the letter L and put it upside down, and it also creates a block. That is how you differentiate the 90 degrees angle from the other angles that you can get. There is also what we call an obtuse angle, which is more than 90 degrees but less than 180. Then we've got a straight angle, which is just a line, and that is exactly 180 degrees. Then we have a reflex angle, which is more than 80 degrees but less than 360 degrees. So then the angle is marked underneath because we are jumping over from 180 and we are now rotating the other direction. Then we have a 360 degrees, which is known as a complete angle or a revolution. That is exactly 360 degrees. So the focus is only on the 90 degrees angle, which is your right angle. Looks like an L and it has a block to indicate that this is a right angle. And it is and will always be equal to 90 degrees. Not less, not more, but exactly 90 degrees. With that information in mind, boys and girls, I need you to do page 29 for me. Now on page 29, you are going to focus on piece number 5 of the puzzle, this part over here. Then you will do A for me. A is asking you how many right angles are in picture 5. So you will look for the right angle there and tell me how many right angles did you find. Then for B, you're going to tell me if you can draw a triangle that has got 2 right angles. If you can, please draw it. If you cannot, explain why you can't. Then for C, you are going to construct a triangle that looks like piece number 5, but you need to make it bigger. And for this, you will use 3 puzzle pieces. For example, you may use, let's say now they were asking you to use 2. I don't want to make an example of 3 because then I'll be giving the answers away. Let's say you were asked to make a puzzle which looks exactly like picture number 5, or rather puzzle piece number 5. I would use number 1 and number 2. That's exactly the same. But now you are going to make the same one just a little bit bigger using 3 pieces. Say for example, piece number 6, number 4 and number 6. Your choice. Then you need to construct a triangle again that looks like piece number 5, but then you will make it bigger again. But now you will use 4 puzzle pieces. For example, piece number 7, piece number 6, piece number 4, and piece number 2 to make a triangle that looks like this, just a bigger version. Then next, you're going to use a geoboard and elastics, but that is now if we were at school. For now, because you're not at school, you're going to make use of the grid that's given to you on page 29. And you are going to investigate how many different right angle triangles you can make on a 4x4 geoboard. Now, a geoboard is something that looks like a grid that's given to you on page 29. Therefore, make use of that grid. So you're going to record your findings and explain how you determine that the triangles are different. So you are going to draw as many different right angles triangles you can make on this space that's given to you on page 29, and then you are going to tell me how are the triangles, or how did you determine that the triangles are different. So maybe you can tell me that, okay, the position of the triangles is different, and maybe the triangles are exactly the same, but they are just translated, something like that, whatever your observation or your findings of the investigation will be. And that's all for today. Thank you so much for your time, and mine is up. Hope you enjoyed the activity.